Hello friends, next method is the tangential method, which is the last method in the tachyometry. We are going to see the difference between the stadia method and the tangential method. In tangential method, we require the normal theodolite, and we are not going to use, even the three crosses are available, we are not going to use the top and the bottom, only we are going to use the middle, right? So such that I need to have two elevational angles to be measured to determine the elevation of a particular point, either in the elevation or in the depression, right? I need to measure two vertical angles, right? See, this is the first case. If the object at elevational point and I am able to hold the staff over that point also, now I have set my instrument at position P and the height of instrument is H and the normal horizontal line of sight is this. From the normal horizontal line of sight to the first bottom reading is called as V, and from the staff ground position to the bottom is denoted as R, and the second reading gap S1 to S2, that gap is the staff intercept. This gap can be freezed by the surveyor, that is by ourselves, right? How I can have the S value as 1.5 or 2, I can have 1.5 based on the field condition and my requirement, right? This gap can be fixed such that if the first angle, say theta 1 at one reading, then I need to add my fixed S such that till that reading I need to move my telescope in the vertical direction, the vertical circle, right? Then I will get the theta 2. The difference between the S2 and S1 is fixed by me, right? Now the distance from the instrument position to that point is D. So the V can be obtained with respect to the first angle, theta 1. Tan theta 1 is equal to V by D. So V is equal to D tan theta 1. And next, based on the S1 intercept, V plus S is equal to D tan theta 2. We required the D since S is fixed, right? So by equating these two equation, if you make subtraction, minus plus, it will cancel. The S is equal to, you get D tan theta 2 minus tan theta 1. The D becomes common, right? And the unknown here is D. S is known, theta 1 and theta 2 from the theodolite we can obtain. So the D is equal to S tan theta 2 by tan theta 1. It is the first equation. From that we can obtain V is equal to, you substitute the D value here, so S tan theta 1 by tan theta 2 minus tan theta 1. Therefore the RL of Q can be obtained by the RL of P plus the staff height at the benchmark gives the height of instrument plus V minus R, right? That is the formula to be used, where H is the height of instrument and R is the staff reading corresponding to the lower. This is the case where the object at elevation, both the angle at elevation, right? That is the heading when both vertical angles are at elevation. Next condition, if the instrument position is such a way that the point required is in the depression, so we compare to this, it is in depression, the same Q, and the same distance notation D is adopted. From the horizontal line of sight to the S1 only is V. Don't change the notation. From the horizontal line of sight to the S1 is denoted by V, and S2 minus S1 is the S. This is fixed by ourselves, right? So, and from the bottom of the staff to the bottom intercept is denoted by R, and here the theta 1 will be greater than the theta 2. Here theta 1 will be lesser than the theta 2. The difference you have to understood, right? So in this case, again the triangle principle only we are using. With respect to theta 1, V is equal to d tan theta 1, and with respect to theta 2, here C, V minus S has to be done for this triangle, right? So V minus S equal to d tan theta 2. So by equating both the thing, you will obtain S is equal to d tan theta 1 minus tan theta 2. Therefore the unknown is d. S tan theta 1, sorry, here it is tan theta 1 minus tan theta 2, right? So V is equal to tan theta 1 by tan theta 1 minus tan theta 2. But here see the reverse, here tan theta 2 minus tan theta 1, here it is tan theta 1 minus tan theta 2. The difference you have to now the R of Q can be obtained, the R of P plus the height of instrument minus V minus R, right? This is the case where when both vertical angles are in depression. The third case is when one angle at elevation and one angle at depression, right? This may happen based on the terrain condition also, right? Such that what will be that? Always remember the normal horizontal side to the bottom reading is V. In the tangential you have to remember the normal horizontal side to the bottom reading is V, and the difference between S2 and S1 is again S. This is fixed by ourselves, and from the ground point to that bottom stadia reading is R, and to the top we measured a vertical angle theta 2, for the bottom we measured angle theta 1, and the same distance was denoted. So from the bottom triangle, tan theta 1 is equal to V by D, so V is equal to d tan theta 1, and in this case tan theta 2 is equal to this opposite by D. What is this? We can get is S minus V, right? So S minus V is equal to d tan theta 2. By equating the equation, you will get S is equal to d tan theta 2 plus tan theta 1, that is theta 1 plus theta 2, right? So V is equal to S tan theta 1 by tan theta 1 plus theta 2. This third case, the denominator has the positive sign, right? So therefore R of Q can be obtained as R of P plus H minus V minus R. It's look like similar in depression. The top portion is only for the calculation purpose, right? These are the three cases you have to remember. So this is the tangential method where we are able to hold the staff over the required station. In such condition only tangential method is possible. And in the stadia method also we need to measure the 3 cross reading. There also where we need to hold the staff over the station. If it is not possible, the theodolite we have seen in the third unit, that is the way where trigonometrical leveling principle is the only solution, where we can't hold, the base is not accessible, right? So these are the difference you have to remember. Stadia method and the tangential method difference. In stadia system, fixed hair method and movable hair method are used to find out horizontal distance. In tangential, various cases are being used to find out the horizontal distance. There are 3 cases. In stadia system, a telescope is fitted with the stadia hair in movable hair method. In tangential, a telescope is not fitted with stadia diaphragm itself. Two vein or targets are fixed at a known distance apart, normally 3 meter, that is substance bar method. Two targets are fixed distance apart is probably 3 to 4 meter. In the leveling staff it can be possible. In stadia system there is more speed and readings are easily be taken. In tangential there is a less speed and reading are not easily been, since two vertical angle has to be noted down. Stadia method with the staff being held vertically is in common use, but normal holding staff it is may create the error, right? So predominantly vertical hold only used. Tangential method or system is not in common use. These are the difference you have to remember, right? So I repeat, the advantage of the tachometric surveying over the direct method is it is speed of surveying is very high, accuracy of surveying is quite satisfactory in normal condition and even superior in difficult terrain. Cost of surveying is less, not tedious as chain, tape, ranging rod, etc. are avoided. The method is more advantageous in the following work: preparation of topographic plan, recognition survey of roads and railways, hydrographic survey, checking already measured distance for filling in details in a traverse, right? Thank you, friends.